Section 5.1 is on page 316. Talks about graphing rational functions. What a rational function is: the quotient of two polynomials in which the denominator doesn't equal 0. There are four main components for us to be able to sketch the graph of a rational function. Three of which are, I think, straightforward. One is a bit tricky. Now, I want to take 1 over x and choose values for x. And I'm going to get my calculator out and figure out what these values are. So I want to choose for x equal 10, then 100, then 1,000, then 10,000, right? So I want to take x and make x grow. Basically, this is the notation. X grows as x gets bigger and bigger. What happens to this? Well, if x is 10, I could take 1 divided by 10. This is going to, okay, 0.1. So this is 0.1. If x is 100, what's 1 divided by 100? 0.01. So do we see where this is coming? Whatever x is, I'm throwing that in, and I'm trying to figure out what is this. What's going to happen to this? This is going to approach what as x grow? Well, I started with x equal 10, but I want x to be very big, so I chose 100 next. I got 0.1. Then 1,000. 1 divided by 1,000 is 0.001. 1 over 10,000, 0.0001. Do we agree that x, as x grows, this fraction 1 over x is going to approach 0? What if I wanted to go negative? What if I chose negative 10? What is 1 divided by negative 10? That is negative 0.1. And if I went to negative 100, that's negative 0.01. Okay. And if I go to 1,000, I'll get negative 0.001. So do we agree that as x grows to infinity, or as x grows to negative infinity, it seems this is approaching 0 regardless? So in that sense, if you take any number divided by x, where a could be any number, as x grows, which is our definition of a horizontal asymptote, as x grows, this will approach 0, no matter how big that number is. Why is that? Because we're going to take x to be infinitely large. Now, we're going to do a lot of graphs. These problems are not in your book, they're provided. I'm giving you this sheet. It's already in Canvas. I'm going to upload that in under files. I'm going to upload it in the actual module where there is the lecture. Underneath it will be the homework with the answers. The goal is to graph those. Now, analyze, we really don't care much about analyzing. Let's graph. And to graph those, you need to figure out 4 things. 4 main things. And once you get 4 main things out of the way, once you keep track of asymptotes and how the graphs behave, you'll be able to graph no problem. 1, so 4 things we need. 1 is the domain. What's the domain of this problem? And all of these are going to be polynomials divided by a polynomial. They're going to all look like this. Well, domain is actually the denominator not equaling 0. Where does the denominator equal 0? When x equal a 1, I can't have that, and x equal a negative 2. So, domain is always vertical asymptotes. So we have vertical asymptotes, horizontal asymptotes, Y-intercept and X-intercept. Vertical asymptotes. Those would be always the domain. What's not allowed in the domain? A 1 and a -2. So on a graph, you call that, what's an asymptote? It's a line you get very close to, but you never reach. 2. I would like to know the horizontal asymptote. And this is the tough part. Horizontal asymptote. There are 2 of these types. And let me show you how it works. We apply this analogy. We say, look at this. Just like we did with polynomials. What dominates over the top? Isn't x dominating the top? When you multiply the bottom, what's the leading term? Isn't that x squared? Doesn't this reduce? Isn't that 1 over x? So, horizontal asymptote is every single time taking this and figuring out as x approaches infinity, we agreed that any number over x will approach 0. So we call that horizontal asymptote. I know this seems to be really awkward. After I do 14 examples, this will become a lot more familiar. 3 is the easiest of them. Y-intercept. And the reason it's easiest, you replace 0 in for x right there. So if I replace x by 0, a 0 there, a 0 there, a 0 there, look what happens. I'll get 0 over -1 times 2. Isn't that 0? So, 4, and lastly, that's all we need, X-intercept. The X-intercept is when you replace y by 0. And you agree that, we already did this, a fraction equals 0, a over b equals 0, if and only if the top equals 0, only the top. So where does the top equal 0? That's when x equals 0. That's it. I find those. Now finding those, again, I'm going to do that on every problem, not to worry. How are we going to put those on the graph? I'm not going to sketch the graph yet, I'm just going to put what I have. Vertical asymptote is what the domain doesn't allow. X equal 1 is not allowed. You put a vertical line on the graph indicating, hey, that's not in the domain. X equal -2, you put a vertical line indicating you can never cross that. That's not in the domain. Horizontal asymptote is y equals 0. Y equals 0 is this line. Now, a graph must pass through its intercepts. This graph must cross through 0, 0. So, vertical asymptotes are impossible to pass. Horizontal asymptotes, you pass roughly 15% of the time. I'm not going to go for the graph yet. I'm going to go for the second problem, and I'm going to do the same thing. I'm going to look at this problem, say, alright, well, let's do the same. To do that, I'm going to factor the denominator. Isn't the denominator x minus 3 into x plus 2? 1. I need the vertical asymptote. That's the domain. 2. I need the horizontal asymptote. 3. I need the y-intercept. That's the easiest. Why is that? Replace x by 0. There's only one of those. And 4. I need the x-intercept. So, vertical asymptote. If I was to ask you what's the domain on this problem, wouldn't you say the domain for this problem would be all real numbers except x equaling 3, there it is, and -2? Well, that's the beauty of it. Vertical asymptotes will always be the domain. Horizontal asymptote is the tricky part. What dominates over the top? That's the leading term. The denominator x squared. As x grows to infinity, 6 over x grows to 0. 6 over x squared grows to 0 even faster. That's your horizontal asymptote every single time. So you have to do something like that. And it's always y equal whatever that is. If I replace x by 0 right there, wouldn't that be 6 over 0 minus 0 minus 6? Isn't that a -1? And X-Intercept, you always set the top equal to 0. No exceptions. Where does 6 equal 0? 6 can never equal 0. That means this graph doesn't cross the x-axis. Now, I start with my asymptotes. X equal 3. 1, 2, 3. That's a line I'm going to get very close to, but never ever reach. Negative 2, 1, 2. Y equals 0. I should keep in mind a horizontal asymptote. I'm not supposed to cross it, but roughly 15% of the time I cross it. And part of the graph is 0, negative 1. The graph must pass through the point 0, negative 1. That point is on the graph. I'll come back to this. Let's do more. I'm looking at number 20. On number 20, I would like to look at, if I factor this, isn't this x minus 1 into x plus 1? 4 main characteristics. 1, the vertical asymptote, that's always the domain. What's the domain on this problem? X cannot equal what? A 1 or a negative 1? There it is. 2, horizontal asymptote. Y equal, what dominates the top? The leading term on the top is a 3x. The leading term of the denominator is an x squared. Doesn't this cancel one of those and you left with 3 over x? Any number over x approaches 0. There it is. 3. What is the y-intercept? If I replace x by 0, what do I get? So I'll get 0 over negative 1, which is 0. And 4, x-intercept. That is always setting this top equal to 0. So I have a vertical asymptote at 1. This graph can never cross x equal 1 because that's not in the domain. And I have a negative 1 as well. The graph will never be able to cross those two numbers. I'm going to push that 1 unit down. It seems to be, there we go. And I have a horizontal asymptote if y equals 0. Now you might be thinking that's always the case. I picked those so that I get all of these together. Y equals 0 and so on and so forth. Now if I pick the point on the graph are 0, 0. This graph must cross through the origin. How do you graph? That's coming up. Next problem up, number 22. On number 22, 1, domain vertical asymptotes. Doesn't this factor, isn't that x minus 3 into x plus 3? So vertical asymptote, x cannot equal negative 1, a negative 3, or a 3. There are 3 of them. 2, horizontal asymptote, y equal, you look for dominating term. What dominates the top? Negative 4. If you multiply those out, isn't the denominator dominated by x cubed? Any quantity over x will approach 0. That would be my horizontal asymptote. 3, find the y-intercept. Replace x by 0. Negative 4 over, a 0 in there will get you a 1. A 0 in there will get you a negative 9. Negative 4 over negative 9 is positive 4 over 9. 4, and the last property we need, x-intercept. Where does the graph cross the x-axis? Set x equal to y. That is, where does the top equal 0? Do we agree that negative 4 can never equal 0? That means this graph doesn't cross the x-axis. I have 3 asymptotes, x equal negative 1. I'm going to move this down a bit. I keep on doing the same thing, huh? X equal negative 3. And x equal 3. I have a horizontal asymptote of y equals 0. By the way, that's the worst case, and the graph crosses at 0, 4/9. There we go. Got it. Not bad. Now, how about number 10? One, vertical asymptotes. What's the domain? X cannot be 1. I'm going to mark that as a vertical asymptote, indicating you can never reach that. 2, horizontal asymptote. Y equals 0. Not so fast, you guys. What dominates over the top? Isn't 2x the leading term? X. Do you notice those cancel out? Aren't you left with 2? And it's always y equal whatever comes out of this. And in this case, it happened to be a 2. 3, Y-intercept. If I replace x by 0, right there, I'll get 0 plus 4 over negative 1. That's negative 4. And 4, X-intercept. So you notice we use each of those. The top, the bottom. If I set y equal to 0, that's really setting the top equal to 0. Where does 2x plus 4 equal to 0? Isn't that when x is negative 2? Asymptote. Only one of them. X equal 1. Right there. Horizontal asymptote. Y equal 2. 1, 2. You know what? This one I think I have to scale. I'm going to say this is 1, this is 2. Now, the graph. It must cross through 0, negative 4, and negative 2, 0. I'll come to this graph in a bit. For now, let me go on and do the rest. How about the next problem down? 1. I'm going to factor this. Isn't the top x plus 4 into x minus 3? Isn't the bottom x minus 2 into x plus 2? So 1, vertical asymptote. Isn't the domain you cannot have a negative 2 or a 2? Horizontal asymptote, it's always this dominance business. Y equal. What dominates the top? Isn't that x squared? What dominates the bottom? Isn't that x squared? Don't these cancel out and you're left with a 1? So it's always a bit of work. 3, Y-intercept. Replace x by 0. Put a 0 in for all of these x's that you see. A 0 there, a 0 there. Isn't that a negative 12? A 0 there. Isn't that a negative 4? Negative 12 divided by negative 4. Isn't that a 3? And how about an X-intercept? Basically, where does the top equal to 0? Where does this equal 0? That happens at 2 values. Do you see that? Let me get a bit more space. So this time it happened there are 2 of them. And that's at negative 4 and at 3. Now, to the graph. Vertical asymptote, x equal 2. Let me center that a bit better. 1, 2. Negative 2. Negative 1, negative 2. Horizontal asymptote, y equal 1. I have intercepts. The graph crosses at 0, 3, negative 4, 0, and 3, 0. I just want to fix this a bit better. Okay, now, a couple more to go. I'd like to look at this problem as well. Same deal. 1. Vertical asymptotes. Domain x cannot be 0 or 4, two of them. Horizontal asymptote, it's always this. They call it limit in calculus. What dominates the top? If you multiply those out, isn't that x cubed? And if you multiply this x squared times x, isn't that x cubed? Isn't that a 1? So horizontal asymptote is always some mark. 3. Y-intercept. Replace x by 0. Put a 0 right there, that's a negative 1. Put a 0 right there, that's a 2. Put a 0 right there, that's a negative 3. Put a 0 right there, we have a problem. We have a 0 in the denominator, which means this graph does not cross the y-axis. 4. X-intercept. Well, to find the x-intercept, we set y equal to 0. On this equation, set the top equal to 0. There are 3 of those values for this. Where does this equal 0 at 1? Where does this equal 0 at negative 2? And this will equal 0 at 3. To the graph, I'm gonna label asymptotes. A graph can't be 0. The graph can't touch at 4. Y cannot be 1. The graph must pass through its intercepts. It's never going to cross the y-axis. 1, 0 is 1 point. Negative 2, 0 is another point. Oh. And 3, 0, 1, 2, 3. I'll come back to that. We're almost done with this. We'll continue this in the next video.